All right, so we are going to look at these examples. And let's see here. We start at 8 and it goes to 21. So it really doesn't matter if we do evens or odds today because of the fact that they are both going to be the same amount. There's not one more than the other. So I'm just going to start off at the very beginning. We will do number 8 since we did the odds up here. So we'll go ahead and do the even problems. And I'm even going to go through a couple of vocabulary terms as well as some other of the problems just so we have other examples to go along with. Okay. So looking at number 8, it says evaluate 10.2x plus 9.4y when x equals 2 and y equals 3. Now this word evaluate simply means to solve. It wants us to solve this equation whenever we plug in these two numbers. Now we did discuss as well that we're just going to be plugging in 2 every time you see x and 3 every time you see y. So for this first example, x is multiplied by 10.2. So I'm just going to write a 2 in there, 10.2 times 2, because we're just replacing that. We're plugging in that 2. Same ordeal, 9.4 times blank. There's a y there, so I'm just plugging in that value for y. After we plug in those values, you simply solve. 10.2 times 2 is going to be 20.4 plus 28.2, which is 9.4 times 3. You will add those together to get our final answer of 48.6. That is it. Don't let the fact that with number 9 having this fraction or having these fractions change that result. T is equal to 1/4. And you have 1 t there. You're going to plug in 1/4 where that t is and solve. Now keep in mind whenever you are multiplying by fractions, it's numerator times numerator as well as denominator times denominator. So just keep that in mind whenever you multiply by fractions. There is a rule, which is just numerator times numerator and denominator times denominator. Number 10 says, write an expression that represents the height of a tree that began at 6 feet and increases by 2 feet per year. Let y represent the number of years. Now, something that we talked about in class as well is the difference between your constant and a coefficient. A constant is going to be the amount that will not change. So, write an expression that represents the height of a tree that began at 6 feet. This 6 would be our constant. With it being our constant, we will not multiply that by anything. So therefore, it will be left by itself, 6 plus something. Well, 6 plus what? The only other number, it says that it increases by 2 feet per year. This increase is represented with your addition and increases 2 feet per year. Now, the reason why we use 2 times y is because of this per. Per represents multiplication. So 2 feet per year, that's going to be 2 times the amount of years that this tree grows. So after the first year, it'll grow another 2 feet. After 2 years, it'll grow in another 4 feet, so on and so forth. But something to help with this is definitely identifying the constant, which is that 6, and then that coefficient, which is that 2. Really easy peasy stuff there. Going on to 12, it says 0.5. It just wants us to evaluate each expression for the given value. Keep in mind, we said up here, evaluate simply means to solve. Evaluate simply means to solve each expression for the given value of the variables. Right now, I have an F where F is 12, and I have a G where G equals 2. I'm going to plug it in first and then go through the process of solving. 0.5 times 12. I see the F, I just plug it in. Minus 2.3 times 2. You just plug it in. After you plug it in, you really do just go through the process of solving. Now, please keep in mind as well, you will need to keep in mind your order of operations. A lot of the times we refer this to PEMDAS, where P is parentheses, then E is exponents, multiply, divide, add, and subtract. The only good thing to note is that you can multiply and divide at the same time, if at all possible. Same ordeal. You can add and subtract at the same time when at all possible. So therefore, we're going to multiply first before subtracting. 0.5 times 12 is 6. Don't do anything with that minus sign yet. You bring it on down and then do 2.3 times 2, which is 4.6. 6 minus 4.6 is going to be a 1.4. Now, this next one is using fractions, which is okay. We're going to go back to numerator times numerator and denominator times denominator. W equals negative 1/2. Now, that negative 1/2 is important. So 34, there's nothing happening to it, so I leave it alone. Plus 4/9 times a negative 1/2. Now, I'm going to move my work over to the side so I have a little bit more room and so I can really show what's going on here. 34, we're going to leave alone right now. We're not going to touch it. I'm also going to leave the plus sign alone for the time being. I'm primarily going to focus on this 4/9 times, because keep in mind if it's in parentheses, it's multiplication, a negative 1/2. I'm going to focus on what I just wrote in blue. So we have to multiply first. So once again, leaving the 34 alone, and I'm going to leave the plus sign alone. Now, what I'm working in blue, it's numerator times numerator. 4 times negative 1. When you are dealing with multiplication, a positive times a negative will give you a negative, number. So whenever we're just looking at the numerators, 4 times negative 1, well, that's going to be a negative 4. 4 times 1 is 4, but I have a negative there, so it's a negative 4. Divided by, now do denominator times denominator. 9 times 2. Well, 9 times 2 is 18. Notice here that I did not mix this. I kept 4 minus 1. I kept my numerators on top. And then I have a 9 times 2 on the bottom. My negative sign did not apply to both numbers, just my first one, which gave me a negative 4/18. Now, this can simplify, but I'm not going to do that just yet. My next step I'm going to do, I have plus a negative, plus a negative. Leave my 34 alone for now, but plus a negative number is simply going to be subtraction. So my plus and negative 4/18 is going to be 34 minus 4/18. And then from there, I can go through the process of solving. Now, once again, I can simplify. 2 can go into both of these numbers 2 and 9 times. So really, this equation is 34 minus 2 over 9. Now, I've been doing this for a while, so if you do not like to just go ahead and subtract right off the bat, that is completely fine. But I know that this is going to subtract to be a 33 7 over 9. Subtracting 2 9s from 34 is going to leave me 33 7/9. And that was for question 14. There are a lot of steps in this one because we have that fraction applied, but it's all that we've done before. So as long as you take it step by step, you'll be okay. Number 16 says, which expression can be used to determine the total weight of a box that by itself weighs 0.2 kilograms and each P plaques that weigh 1.3 kilograms each? If you want to, and I actually highly suggest this, locate the constant as well as your coefficient. The reason being is because the way that these expressions are set up, it's set by the constant, which I'm actually going to go back and use that letter K. We used that letter K to represent a constant before, so we're going to do it again. My constant's going to be K plus my coefficient times a letter. So I'm going to change this. I'm going to do a number, which is the coefficient, times a letter. Now, for this letter, I'm just going to use the letter C. So this is how the expressions will be set up with most of the time, especially whenever you're dealing with a constant. So with my constant, this is not going to change. It says, with which expression can be used to determine the total weight of a box that by itself weighs 0.2 kilograms. What this means is that this box by itself is going to be 0.2. So that is your constant, is 0.2 kilograms. Now, another reason why I'm making this the constant is because the next part says contains P plaques that weigh 1.3 kilograms each. That big word there is going to represent that this is my P plaques. Each plaque weighs 1.3 kilograms, and from there I can have 1 plaque, 2 plaques, 3 plaques, 4 plaques, so on and so forth. So that's going to be my coefficient. Now I just need to plug it into the correct equation. My K, my constant, we stated was that 0.2. My coefficient, we said, was that 1.3 times. We don't need to put that C because we're told that the plaque, that letter, will be represented by P. Which equation shows that? Well, it's going to be this one. Even though it's set up a little wonky, all they did was switch these two numbers, which is A-OK, which the addition using the commutative property, you can switch those two. So I'm going to even add that because that is a vocabulary word that we've used in the past. Commutative. Which states that you are allowed to switch when you're looking at addition and multiplication. Now, why did I add and not subtract? Well, whenever you're adding something, with this word contains, we're going to be adding plaques into the box. We're not taking them out. Now, if it said, and each plaque weighs 1.3 kilograms and we're taking them out of the box, then we would subtract. But since we are containing this plaque, since we are adding it to the box weight, we do need that addition. Which brings us to number 18. A full grain silo empties at a constant rate. Write an expression to determine the amount of grain left after S seconds. So with this, we're told a couple of things. Full capacity, this entire silo holds 3,000 feet cubed. Now, all that represents, that's just volume. That's just a fancy way to represent volume. That feet cubed does not mean much to us. Other than that, it empties into the truck at a rate of 3.5 feet cubed, and that slash seconds is the same thing as per seconds. So let's just start off with our constant. At full capacity, the volume of this silo is 3,000. At capacity, it is 3,000. That is our constant. This silo is not going to shrink. It's not going to expand or get bigger. It holds a constant capacity of 3,000 grain, 3,000 feet cubed grain. It empties. Now, emptying, if you are losing volume, or if you are losing, let's just use water. If we put water in this silo instead and you're losing water, that's going to be subtraction. If you're losing something, you are subtracting it at a rate of, we're said, 3.5 feet per second. Now, I said it before, that word per means multiply. So per S means times S. Since we're just using a letter, though, we don't need that multiplication symbol. All we need is that letter S. That's it. Keep in mind an expression. All an expression is an equation without an equal sign. There's nothing fancy to what an equation or what an expression is. It's just an equation without an equal sign. We don't know how many seconds it's been going. We just know to find the amount, we use that expression. And that's it. Which brings us to number 20. Now, number 20 does look like it has two parts. It says Joe bought G gallons of gasoline for $2.85 per gallon and C cans of oil for $3.15 per can. I'm going to highlight a couple of things. He bought G gallons of gas for $2.85 per gallon. Keywords here, and I'm going to stick with yellow. G gallons, $2.85 per gallon. So the number that we have is $2.85 per gallon is times gallons. Now, keep in mind, we aren't given a number, but that's okay. We can still use that letter G. So 285 times G, or just 285G. Going on to the next one, and C cans of oil for $3.15 per can. I'm going to do the exact same thing. C cans for $3.15 per can. So $3.15 per we represent is multiplication per can. Just because we don't have a number doesn't mean we can't still put that C. We're going to use that letter as a placeholder for now. So therefore, I will also have $3.15 per can. Now, when we have a letter, we don't have to write times. We can simply leave it as C. Back to the question, what expression can be used to determine the total amount spent on gas? That word total, that's an easy one. Total means we got to add them up together. So therefore, that's the expression. We don't have to do anything else. That's the expression we use. Part B, we're just going to solve some things. Now, here's the funny part. For part B, we're told that Joe spent $15 total. $15. He bought 2 cans of oil. About how many gallons of gasoline did he buy? So I'm going to start off by writing this expression that we found. 285 times gallons plus 315 times cans equals the total amount he spent is $15. I need to solve for G, which is gallons. Now, I am told, though, that he bought 2 cans of oil, so I'm just going to plug that in for C, 3.5 times 2, because he bought 2 cans. Then we're going to go through the process of solving. 2.85 G, I can't do anything with that yet. Plus 315 times 2, I can go ahead and multiply. This is going to be 6.30. Since it's money, I'm going to go ahead and add this note here. When you're dealing with money, moolah moolah, I like to keep it in the hundreds. Keep in the hundredths place. Because even though, yes, we could just have this as 6.3, it's still a little bit easier to just keep it in the hundreds because that's how money is represented. We always do it to the hundreds place. Equals 15. Now, here's the tricky part. How do I get G by itself? You remember PEMDAS? When solving for a variable, you need to do PEMDAS backwards. That's kind of how to remember it. So I'm just going to write PEMDAS. And we have to go backwards when solving for a variable or solving for a letter. Meaning I'm going to start off with addition and subtraction and work backwards. So right now I have 2.5G plus 6.3. If I'm working backwards, I'm going to be looking at this plus 6.3 or 6.30. I got to do the opposite. So do the opposite. What's the opposite of addition? Well, it's subtraction. Subtract, that's 6.30, not just on one side, but on both sides. That is going to be 8.70. So once again, after we do that subtraction, I am going to have my 2.85G stays the same. 6.30 minus 6.30, well, that's just 0. Equals 8.70, which once again, we're dealing with money. I'm going to keep it in the hundreds place. I don't need to have this 0 here simply because of the fact that anything plus 0 is just itself. So I'm going to go ahead and move on to the next step. The next step is dealing with any multiplication and division. Right now I have 2.85 times G. The opposite of multiplication will be division. What I do to one side, gotta do to the other side. So now I'm gonna have 2.85 divided by 2.85. Well, that is just 1. So I'm gonna write that out. That is just a 1, more specifically 1G, because you have to keep your G coming along. I'm not going to write that plus 0 anymore. There's no need to. equals, now this 8.7 divided by 2.85, I don't mind if you use a calculator. This is rounded to 3.05263. And once again, we don't need that 1 here, so I'm just going to go ahead and erase it. So our total amount of gallons is 3.05263. This word about means that we need to estimate. I'm going to do this really quick and easy. To estimate. It looks like I have the tens place. So I'm going to look at the tens place and look behind it. Well, really, I don't even need to do that far. Which one of these 4 answers is closest to 3.05263? Well, this is going to be the closest to just plain Jane 3. It's a little bit too far from 3.5, but it's 0.05263 away from the number 3. So really, this would have even rounded to 3.1, just 3.1, which is still closer to the number 3. And that's it. You have the odd problems to work on now. This one was short, sweet, and easy. You have the odd problems. If you have any questions at all, please feel free to let me know, and I'd be more than happy to help you guys out. Thank y'all so much.